Okay, we're going to go ahead and begin our Zoom session 2 for week 2 of Survey of Contemporary Mathematics. This week we're going to be studying chapters 4 and 5. And in chapter 4, we're going to be looking at ratios and proportions. So just a couple of notes and examples as we begin. A ratio is a comparison of two quantities that have the same unit. So in example 1, it says to write the comparison as a ratio in simplest form using a fraction, a colon, and the word to. There's actually 3 different ways to represent a ratio: a fraction, a colon, or using the word to. And just one second. Okay, and make sure as you do your apply that you give the specific form that the problem is asking for. It may be asking for a fraction answer, it may ask for a colon answer, or using the word to, so you want to be specific to give it in that way. But in this problem, we have 6 pounds to 8 pounds. Notice they are the same unit of measure, both are in pounds, so that's what makes it a ratio. So we can set up 6 pounds to 8 pounds, and because they are the same unit of measure, those end up canceling, and I'm left with 6 over 8, which can reduce. Both the numerator and the denominator are divisible by 2, and that equals 3 to 4. So that is a fraction answer. We can give that answer using a colon, and then you can write that using the word to, 3 to 4. Either way you write it, it's still read 3 to 4. So instead of 3/4, we read that 3 to 4, or as a colon, 3 to 4. So make sure to give it in simplest form, reduce that fraction completely, and give it in whatever format that the problem is asking for. All right, a couple other definitions. A rate is a comparison of two quantities of different units. So it's really a lot like setting up a ratio, except these will have different units of measure. A unit rate is a rate that has a denominator of 1. So it's like setting up a rate, but finding how many miles per 1 gallon of gas, or how many miles you travel in 1 hour. So that unit rate would break it down, having a denominator of 1. In example 2, it says write each phrase as a rate in simplest form. We have 30 ounces and 24 glasses. So I'll set that up: 30 ounces over 24 glasses. And I can't cancel these units because they're not the same, but I can reduce my fraction down to lowest terms. Both the numerator and the denominator are divisible by 6. So that would be 5 ounces to 4 glasses. When you put that in your Excel document, you can just, of course, write that with the slash. But make sure to give the full label because that's a part of your answer as well. 5 ounces to 8 glasses. All right, in example 3, we're asked to write this phrase as a unit rate. We have $3,900 earned in 4 weeks. So I want to know how much is earned in 1 week. So we've got $3,900 in 4 weeks. So if I take my calculator and divide 3,900 by 4, then that is equal to $975 per week. Once again, you don't have to put a 1 there, but it's understood to be a 1 as we give that as a unit rate. Make sure to give your label, which was money, and the time, weeks. So 975 per week. So there'll be some problems as simple as setting those up as a ratio, unit rate, or a rate. Just make sure if it's asking for a unit rate that you give that per 1 item, whatever it is you're looking for. A new definition is a proportion, and it says a proportion states that 2 ratios are equal, and you can solve proportions by finding cross products. In example 4, it says to determine whether the proportion is true or not, does 4/8 equal 10/20? And one way to check that is by cross multiplying, because if these ratios are proportional, then their cross product should be equal. So 4 times 20 is 80. 8 times 10 is also 80. So because their cross products are equal, we would say, yes, these are proportional. That would be a true statement. Do the same here. Is 7/8 equal to 11/12? Well, I'm going to cross multiply to find out. 7 times 12 is 84, but 8 times 11 is 88. And because those are not equal, then we would say this is not true. These are not proportional. So you can test to see whether two ratios are proportional by finding their cross products. There's quite a few questions on the apply this week concerning cross products and solving proportions. Okay, in example 5, we're actually asked to solve the proportion. We have an unknown value in part of that ratio. So one way we solve proportions is by using cross products. If necessary, we'll round our answer to the nearest hundredths place. We solve proportions by cross multiplying. 8 times x is 8x, and 6 times 4 is 24. This is actually just a one-step algebraic equation. I can solve for x by dividing both sides by 8. Something times 8 is 24, and if I divide 24 by 8, I see that that number is 3. So that's saying that 3/4 is equivalent to 6/8. If you have any questions as I'm going through these examples, don't hesitate to jump in and ask. You can unmute yourself if you need to ask any questions along the way. Okay. This next example, I have 12/18 is equal to something over 9. So I'm going to continue to use cross products to solve that proportion. 18 times x has to equal 9 times 12, and that number is 108. So I can solve this by dividing both sides by 18. 108 divided by 18 is equal to 6. Now, if this was a decimal answer, I'm sure you're going to get those kinds of answers on your assignments this week. If it asks you to round to a specific decimal place, be sure to remember those rules. I'm just going to give you a random number so we can just talk about rounding to the nearest hundredths place. This second digit is the hundredths place, and you have to look at the number directly behind it to decide if it stays a 2 or becomes a 3. In this case, it would just stay 4.12, and you write nothing past that hundredths place. If that had been something like this, well, actually, let me change that to an 8. This is still the hundredths place, but I look at that number directly behind it. In this case, it's an 8, so 5 or more will round that up to a 3. So pay attention to the location that it's asking you to round to and follow those rounding rules in order to give that answer correctly. I want to give you some word problems that go along with Chapter 4. There's quite a few in our apply this week, and I want you to see how to set up ratios and use cross products to solve proportions as it relates to this lesson. These are some additional questions that I've gotten off of page 197 out of your textbook, so you're welcome to follow along in those problems. This is numbers 20, 23, and 30. Number 20 says, the property tax on a $245,000 home is $4,900. At that same rate, what is the property tax on a home valued at $320,000? Because it's telling us at this same rate, we want to know what value would make this relationship proportional. So I'm going to set up a ratio, and the thing about setting up a proportion is you've got to be consistent on the left and the right side. So if I find the value of the home over that tax on that home, I need to make sure that I set the left and the right side up in that same way. So this home is valued at $245,000, and the tax on that home is $4,900. So at that same rate, a value of a home of $320,000 would have a property tax of how much? That's what is missing. What is the property tax on that home? So I've got value over tax equals value over tax. it really would not matter if I put tax over value as long as I'm consistent in the left and the right hand side. So we can solve this proportion by cross multiplying. 320,000 times 4,900. This is going to be a big number here. And then we always divide by the number in front of that decimal to solve for the unknown here. I could actually reduce these 3 zeros with these 3 zeros just to help this be a little bit easier to type into my calculator. But I'm dividing the numerator by the denominator, and that gives me a tax value of $6,400. So if our information is proportional and it says at that same rate, so we're assuming that it is proportional, we can set up two ratios equal to each other and cross multiply to find that missing value. Number 23 says a brick wall is 40 feet in length and it contains 448 concrete blocks. So at that same rate, how many blocks would it take to build a wall that is 120 feet in length? So they're giving me the length of that wall and then the number of blocks that are required to form that wall. In the first set of information, we have a 40-foot wall and 448 blocks. Okay. So on the other side, I'm going to have to also set the length over the number of blocks. It's a 120-foot wall, but the question is how many blocks are going to be required to form that wall up. So I've got feet over blocks equals feet over blocks, and then we can cross multiply to find that missing value. So 40 times some unknown equals 448 times 120. Just multiplying that in my calculator, that's 53,760. And then to solve the proportion, we divide by that number in front of the variable there. So numerator divided by the denominator, that gives me 1,344 blocks are necessary. Okay. You could check your proportions. If you said 40 divided by 448 in your calculator, you'll get a decimal. Then take 120 divided by 1,344, you should get that exact same decimal. So that's one way to check and compare. Make sure you solve that correctly. Also, cross products should be equal. So 440 times this number should be 53,760, because cross products are always a way to check to see if two ratios are proportional. Okay, one more. A house had an original value of $160,000, but its value increased to $240,000 in 2 years. Find the ratio as a fraction in simplest form of the increase to the original value. So this is how I'm going to set up that ratio. How much did the house increase to the original value? Remember, 2, that's how we say a ratio. We're putting it as a fraction in simplest form. So that's how I'm going to give my answer. I need you to be really careful on this problem, and you are going to have a problem like this on your apply this week. The increase in value is not $240,000. That is the new value on that home after the increase has been made. So I'm going to have to subtract that new amount minus the old amount to see how much did the house increase. And that's going to be a value of $80,000. So the increase in that home, it went up $80,000, okay, to the original value of $160,000. That's my fraction. Now I'm just going to reduce this. I can cancel out these 3 zeros and these 3 as well. I can actually do that fourth one too. So that gives me 18 over 16, which is 1/2. We read that 1 to 2. So you'll want to put that in simplest form. It asks for a fraction. If it asks for a colon, you would give your answer this way. Using the word 2, you would give your answer in this form, but be specific to give it your answer as it asks. So the increase in value was $80,000 to the original value of $160,000. You can divide that in your calculator. and convert that back into a fraction, or we're simply just reducing that down to lowest terms. I could cancel 4 zeros on top with 4 zeros on the bottom, leaving 8 over 16, which both are divisible by 8, and that gave me 1 to 2 as my answer. Okay, so that's what chapter 4 is going to look like. Setting up ratios, finding unit rates, and solving proportions. So you may want to go back over those notes and examples at a later time as you prepare for this week's apply. All right, chapter 5 is mainly about percents and converting percents to decimals or fractions or in any form of that. So one note that you need to be aware of is that percent means parts of 100. Percent is how many part of the whole do you have. So remember, this is the symbol that we use for percent. So if your answer is a percent, you'll want to make sure that you label that correctly. In example 1, it says write the percent as a decimal and as a fraction. So I have 72%. If percent means per 100 or parts of 100, then in order to convert that to a fraction, all I have to do is drop the percent sign and take that number and write it over 100. That is a fraction. And then, of course, I would want to reduce my fraction to lowest terms. Both the numerator and the denominator here are divisible by, I could start by 2, but I can go in 4 times as well, and that gives me the fraction 18 over 25. But this form right here is also very helpful in allowing me to convert this fraction into a decimal, because I read that 72 hundredths, and that's what also allows me to write that as a decimal, 72 hundredths. The hundredths place is 2 positions past the decimal. So drop your percent, write that number over 100. There's your fraction. Reduce it if possible. Take this number, 72 hundredths, and you'll write that as a decimal. Okay, so that's just one way to do it. I want to show you how to set this one up an alternate way, because this one actually contains a decimal. And what you've got to be careful about is you can't just drop that percent sign and say, well, this is equal to 25.4. That's not my decimal. Remember, we can drop that percent and divide it by 100. If that percent is not there, that divided by 100 better be there, because that's what we replace that percent sign with. We learned in a previous lesson that when I divide by 100, my decimal gets smaller, and I can move that decimal backwards 2 places. So this is actually the same as 0.254 or 254 thousandths. When we divide by 100, we shift that decimal 2 spots to the left. So the decimal answer is going to be 254 thousandths. I can put a 0 there. That also is how I can convert this into a fraction. 254 thousandths is my fraction answer. And I'll want to simplify that as much as possible. I know both of these are even, so I can divide it by 2. I can cut each of those numbers in half, and I'll get 127 over 500. I think that's as far as that one can go. So I'm going to try this method again for this next problem. This is 0.25%. My decimal is not equivalent to 0.25, but what I have to do is drop the percent and divide that by 100. And mentally dividing by 100 shifts that decimal 2 spots to the left. So that would be the same as 0.0025. Okay, that's my decimal answer. This is tenths, hundredths, thousandths, 10 thousandths. So that's 25 10 thousandths as a fraction. And both the numerator and the denominator are divisible by 25, so that would be 1 over 400. So be able to take a percent and convert it into a fraction or a decimal. Back up here, this was a whole number, so the decimal is understood to be at the back. So I could have done it the same way by shifting that decimal point over, and I would still get 72 hundredths in that way. All right, my next 2 examples says to take the decimals and write them as a percent. Well, if I can read this properly, then I can go straight from the decimal to the percentage through a fraction. But remember, Converting from a percent to a fraction, I divided by 100. Even as a decimal, I divided by 100. So if I want to take a decimal and turn it into a percent, I'm going to multiply by 100 instead. And when I multiply by 100, my number gets bigger. It's got 2 zeros, so I'm going to shift that decimal 2 spots to the right. This is the same as 16%. This one, if I multiply by 100%, shift that decimal 2 spots to the right, that would be 101.2%. That's my decimal, my percent answer from that decimal. So dividing by 100, we shift our decimal to the left. Multiplying by 100, we shift our decimal 2 spots to the right. This next example, these are fractions, but I also want to write them as a percent. Depending on the kind of problem that you have, there's a couple of ways to do this. If it's possible for you to convert your fraction to some number over 100, that really is the simplest way to do this problem. I know that 50 times 2 is 100, so 27 times 2 would be 54, and 54 over 100 is the same as 54%. So if it's possible for you to convert this into some number over 100, then that numerator will be your percentage. It's not going to be quite as simple in this problem right here because I know you can't really think of a number times 8 that would equal 100. So as an alternate way, remember, we can multiply by 100. That would make 500 divided by 8. 8 will go into 56 times at 48. It's a 2. I'm going to bring down the 0. And then 8 goes into 20 twice at 16. I'm going to add a, well, I don't have to add a decimal here, but I will. And I'll bring down another one. So that's going to be 5. So that gives me 62.5%. I could have stopped here at that 4 before I added that decimal. I could have written that as 62 4/8, which is the same as 62 1/2. So either answer is fine. Just be careful if it's a decimal that keeps going that you give that answer properly, or if it asks you to round, make sure you do that as well. If it asks you to round to the nearest whole percent, and that's a big possibility. If it asks you to round to the nearest whole percent, then we would give that answer as 63% because that 5 would round that 2 up to a 3. So just be careful to pay attention to how it asks you to give that answer. All right, so a couple of vocabulary words for math. Anytime you see the word is, that typically means equal, and of normally means multiplication for us. So we're going to look at a couple of word problems here that incorporate those words, and we're going to set up an equation from this statement, and then we're going to try to solve for the missing part. So remember, of means to multiply, is means equal. So I've got 8% times 100 is what? Is some value. So we're going to find out what that is. I can't multiply by percents, so I need to either convert those to fractions or decimals. Remember, percent means per 100, so that is 800ths or 800ths. You can choose any version. I'm going to go with the decimal because in this case, I'm just multiplying it by 100. It's easier to put in my calculator, but mentally, all I have to do is shift that decimal over 2 spaces. So that would be 8. Okay, that's my missing value. 8% of 100 is 8. That's my unknown. Okay. Next one, of means multiply, is means equals. So 27% of 40 is what number? Of means to multiply. So I'm going to take 27%, that's 27 hundredths. I'm going to turn that into a decimal and multiply that times 40.24. 0.27 times 40 would be 10.8. That's my missing value. And then one more. What percent of 70 is 24? Notice this time I'm missing that percent, so I want to be careful to give that answer as it asks. Some unknown, times 75 is 24. So I could rewrite that as 75W equals 24. Maybe that will help you see better how to solve this. But either way, I'm going to be dividing both sides by 75. We divide by the number in front of the decimal. So 24 divided by 75 is 0.32, which is a great answer if it asks for a decimal. Okay, but it asked me for a percent. So I'm going to need to multiply that times 100 and shift that decimal over 2 spaces to get 32%. So be careful to give your answer in the form that it asked for. If it asked for a fraction, that would have been 32 hundredths. Okay, I want to do a couple of word problems from chapter 5. These are some additional questions that I pulled from page 227. It says, Trent missed 9 out of 60 questions on a history exam. What percent of the questions did he answer correctly? So a couple of things. First of all, it asks for a percent answer. Secondly, it wants to know how many he got right. It tells me that he missed 9. Okay, if he missed 9 out of 60, how many did he get right? So 60 minus 9 leaves 51 were correct. He got 51 out of 60 correct on that test. So to convert this to a percent, I'm going to multiply that times 100%. So that's 5,100 divided by 60. I'm going to just bring up my calculator right here. So, 5,100 divided by 60. And that gives me 85%. So that's going to be my answer for this problem. So pay attention. I know you're going to have a question very similar to this week on your apply assignment. It's telling me how many he missed, but I've got to calculate how many he got right and then give that answer as a percentage. Okay, one more word problem. So this is number 24, also on page 227. It says Joshua purchased a camcorder for $980 and he paid a sales tax of 6.25% of that cost. So what was the total cost of the camcorder? Remember, of means multiply. So I'm going to multiply 6.25% times the cost of that camcorder. But remember, we can't multiply by a percentage. So I'm going to have to divide by 100, which shifts that decimal 2 spots to the left. So 0.0625 is what I will multiply times 980, and that gives me a sales tax of $61.25. Now that is just the tax. The camcorder didn't go from $900 to $60. This is the tax alone. It asks me for the total cost of that camcorder. So I'm going to add that sales tax back to the original cost of that camcorder, and that gives me a new price of $1,041.25. So be careful. That was kind of a 2-step problem here because we had to turn our percent to a decimal, multiply by the cost, and then take that tax and add it to the original cost to get the total cost of that camcorder at checkout. So I hope these examples have been helpful to you. If you're watching this video at a later time, our code word tonight is ratio. So be sure to email me a brief summary and include the code word ratio to receive your extra credit points.